Windic cluster analysis is very distinct from factor analysis and structural equation modeling. Because to start with, cluster analysis doesn't have a dependent variable. All it does is, it is taking number of variables and trying to come up with some groupings. That's what. In factor analysis, what we try to do is we are trying to find latent variables. They are hidden variables. They are not the observed variables. But in cluster analysis, our focus is on the actual variables, like protein, sodium, actual variables. We are not looking for a latent variable like health. We are not looking for something like that. Because all we are trying to do is, in that menu, we are trying to say, okay, if we have these different kinds of menus, where there are different ways of constituting best mix of nutrients, different ways of constituting, because we got all this array of variables. But in factor analysis, we are looking for a variable like health. That is what we are after. But we really don't know what health is. So that's when we do factor analysis. But in cluster analysis, we are not interested in a single variable like health. All we are interested is coming up with different packaging of nutrients for health. So it's different ways of packaging nutrients. So these three clusters are different ways of putting together these different nutrients or food, so that people can have same level of health. But we are not focusing on health, but our focus is about the nutrient composition. Structural equation modeling we use, for example, it could be, the first step could be factor analysis, and we found factors or latent variables. But with the factor analysis, because factor analysis only gives us constructs, latent variables. But for us to use structural equation modeling, we must have a theoretical basis. That means health and age, for example. There's a relationship. And there's a theoretical basis for us to say, well, when age increases, health decreases. And there's evidence to that effect. People have done studies, and so therefore there's a theoretical grounding. Right? So then only we will look at the relationship between age and health. Let's say people have done various studies about age of females and the incidence of pneumonia, right? Or age of males and incidence of prostate cancer, and so forth. So different studies have gathered various types of evidence in relation to age and health relationship. And then, but still, all we know is at the operational level, right? The relationship between prostate cancer and men, the relationship between pneumonia and women. Right? But if you want to look at this relationship at a higher level, does age has a relationship with age, then only we will construct structural equation modeling, because there is theoretical backing to say that for men, when the age increases, health decreases. For women, age increases, health decreases. So we want to look at this total relationship at a higher level. So coming back again to cluster analysis, our focus on cluster analysis is on actual variables. real life variables. And then the purpose is to regroup them, for example, to create nutrient packages, right? So that we can put different foods together and make meals, right? But they both, let's say 3 types of meals now we are coming up by using these different ingredients, the nutrient parameters. We come up with different health menus, and they are equally valuable. They are equally healthy. That's what we are doing in cluster analysis.